Sputnik was launched in 1958 and was launched as a surprise by the Russians and started off sort of a Cold War in space. As a result of that, we developed a lot of technology, math, education to help out, create a new generation of engineers so we could catch up with the Russians.
This is a new and strange environment at first, this suddenly finding yourself in orbit.
Eventually, President Kennedy saw it as a challenge and sent us on a course to the moon.
We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Listen, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
Space permeates our daily lives today. The GPS that we use in our car to get from point to point, that's all happening from orbit. The weather we receive at night on the daily weather channel in your local news, that's coming from orbit. So everywhere we look, satellites are having an impact on our daily lives. Sputnik was a basketball-sized satellite that got launched 60 years ago. In the interim, we've developed satellites that are the size of school buses to do the job. Now today, we're turning that around with the miniaturization of technology that's become available, and we're coming back to that CubeSat breadbox Sputnik-sized satellite.
The CubeSat standard was invented by Cal Poly out in San Luis Obispo, and they created what we call a P-pod, which is a polypicosat orbital deployer. And this deployer is sized such that multiple CubeSats can fit into that deployer. And it allows for universities as well as small companies like ours to launch their technology into space and get some space-rated hardware and learn from the space environment in a cost-effective manner.
Champaign-Urbana Aerospace, or CUA for short, spun out of the University of Illinois, the Aerospace Engineering Department in 1998. And the vision is improving the available technologies that the aerospace industry has to enhance flight and space flight. A little more specific vision is with the micropropulsion systems that we do for small spacecraft about the size of a shoebox. We believe our technologies can enhance those systems for both maneuverability and then deorbiting so that ultimately you can help alleviate the ongoing orbital debris problem that is starting to escalate.
We've been at it for 60 years now, launching satellites into orbit, and so it's become a concern that satellites that have gone past their end of life, things that have collided with each other, created debris, which scatters about, there may be a chain reaction eventually, something called a Kessler syndrome that could be set off.
There are presently some 30,000 pieces of space debris in orbit that are bigger than 10 centimeters. These are in low Earth orbit, or abbreviated LEO, and at that orbital altitude, the velocities are on the order of 8 kilometers per second, which translates to about 17,000 miles per hour. One of the critical things is you do not want these objects colliding, because at that kind of speed, two objects that collide end up creating hundreds to thousands of much smaller objects. So the Kessler syndrome is what happens when this becomes a sort of runaway cascade. And now you have so much space debris that you can no longer safely launch any new satellites through that debris field, let alone people. Many companies recognize this Kessler syndrome problem, so they are trying to practice what is called responsible space. And what that means is providing micropropulsion for the satellites, new satellites that are going up.
CUA has developed small, low-risk, cost-effective propulsion technologies that are triple purpose. First, the thrusters can extend your mission by orbit raising to a higher altitude. Second, the thrusters enable orbital collision avoidance. And finally, the thrusters can be used at end of life after the mission has been completed to re-enter Earth's atmosphere, thus decreasing potential orbital debris.
The chip system uses a micro-resistojet, and that superheats the refrigerant, and it comes out as thrust. Main thrust would propel it this way, and then attitude control and rotate, and you can even do true roll maneuvers. The monofilament vaporization propulsion system utilizes a combination of 3D printer technology to feed and melt a plastic fiber and then vaporize it to give you thrust. The FPPT system uses a high voltage discharge to create a plasma that then vaporizes a little bit of Teflon. It also is ionizing that Teflon and using electromagnetic acceleration to get very high velocity out of the ions. Duplex stands for Dual Propulsion Experiment. And so this is a CubeSat that has been funded by NASA, their tipping point program. And what this will do is we're putting one MVP system on one side of the spacecraft, one FPPT system on the other side of the spacecraft. And this will give us flight heritage for both systems so that future customers will have lower risk because the systems have flown, and it will make those systems more commercially marketable. And the launch date is tentatively mid-2022 for Duplex. CUA has had a very positive symbiotic relationship with the University of Illinois for over 20 years now. It allows us to work closely with some of the greatest engineering and scientific minds in the world.
We send our students over to CUA to act as interns. CUA sends tasks and projects over to us to work on and report back to them. So it's a great benefit for students to be able to put their hands on real spaceflight hardware and real spaceflight projects.
I've worked on a few projects with CU Aerospace, starting with the drag sail mission. Its utility or purpose is intended to help mitigate space debris.
Imagine a thin mylar film, thinner than a human hair, that's ejected out the back of the satellite and interacts with what little atmosphere there is up there to create drag. That slows the satellite down and returns it into the atmosphere where it burns up safely. That kind of technology is what we need today to help clear out the low Earth orbit environment.
When companies engage with students while they're in school, on a day-to-day basis, those students can recognize what they're learning really is used in industry. And so when they go and get that job, they'll be coming in knowing how to use their skills. And that is an efficient education. And it's very important for the next generation of the American workforce, not just engineers. And so when companies make that investment, they'll be very competitive in the world.
You know, when I was growing up, space was something that was done in a research lab at a government facility. Very few people got to interact with it. All the superstar engineers were the folks developing satellites. And now you flash forward 40, 50, 60 years, and today students are building satellites right here in our development lab. And so we're starting to see the development of a new generation of commercial space.
I see this expanding wave of space interest and launches to be a really exciting time in our future for the aerospace industry. Innovation is the key element that has driven the aerospace industry over the years, the decades, and it's going to play a critical role as we talk about colonizing Mars and then ultimately reaching out to the stars.